In space exploration, interstellar travel is the ability to travel between stars. It is something every 5-year-old kid in us has a fantasy. Science fiction serials mainstay. In a truly spectacular way, bravely going where no one has gone before. As our rockets and space probes get more capable, the issue of whether we will ever be able to populate the stars arises. Or, failing that, can we at least send space probes to distant planets and have them report back to us what they see? The truth is that interplanetary exploration and travel are technically possible. There is no physics law that expressly prohibits it. But that doesn't mean it'll be easy, and it doesn't imply we'll get there in our lives, much less this century. Several spacecraft are on escape trajectories, which means they are departing the solar system and will never return. NASA's Pioneer, Voyager, and, most recently, New Horizons probes have all begun their lengthy travels outward. The Voyagers are currently regarded to be outside the solar system, which is defined as the zone where the sun's solar wind gives way to galactic background particles and dust. So, that's excellent, we now have interstellar space probes in operation. Except there's a problem, they're going nowhere quickly. Each of these daring cosmic explorers is speeding across space at tens of thousands of kilometers per hour. Because their missions were designed to investigate planets within the solar system, they aren't heading in the direction of any specific star. However, if any of these spacecraft were to travel to Proxima Centauri, our nearest neighbor, which is only 4 light-years away, they would arrive in around 80,000 years. Furthermore, by the time these probes reach somewhere remotely interesting, their nuclear batteries will have long since died, and they will be nothing more than useless hunks of metal hurtling through space. When you think about it, it's not like our forefathers were capable of exploits like hurling random garbage between the stars, but it's also probably not exactly what you pictured interplanetary space travel to be like. A probe must travel extremely quickly to make interstellar traveling more feasible. It's on the order of 1/10 of the speed of light. At that speed, a spacecraft might reach Proxima Centauri in a few decades and return images in a few years, well within a human lifespan. Is it really so unrealistic to expect the mission to be completed by the same person who started it? It takes a lot of energy to go at these speeds. One alternative is to store the energy as fuel on board the spacecraft. However, if that's the case, the extra gasoline adds heft, making it considerably more difficult to accelerate to high speeds. The Breakthrough Starshot project, which aspires to develop a spacecraft capable of reaching the nearest stars in a matter of decades, is based on this concept. In the most basic version of the project, a massive laser with a power of 100 gigawatts fires at a spaceship orbiting Earth. That spaceship is equipped with a big solar sail that is very reflective. The spaceship gains momentum as the laser bounces off the sail. If we discharge this laser at the spacecraft, weighing a gram, weight of a paper clip, for around 10 minutes, it would achieve 1/10 the speed of light. When it comes to getting spacecraft to move at the appropriate speeds, here is where the rubber meets the intergalactic road. The laser itself is many orders of magnitude more powerful than any laser we've ever created, with a power output of 100 gigawatts. To put things in perspective, 100 gigawatts is the aggregate capacity of all nuclear power plants in operation in the United States. A camera, computer, power source, circuits, a shell, an antenna for communication back home, and the entire light sail must be included in the spaceship, which must have a mass of no more than a paper clip. That light sail has to be nearly flawless in terms of reflection. It will convert that energy to heat instead of momentum if it absorbs even a small fraction of the incoming laser radiation. That means straight up melting at 100 gigawatts, which is generally not good for the spacecraft. The actual adventure begins once you've reached 1/10 the speed of light. This tiny spaceship will have to weather the hardships and tribulations of interstellar space for the next 40 years. It will be impacted by dust grains moving at such a high speed. Even while the dust is so fine, at those speeds, motes can cause a lot of harm. The fragile electronics within can be harmed by cosmic rays, which are high-energy particles emitted by everything from the Sun to distant supernova. As soon as the journey begins, the spacecraft will be assaulted by these cosmic rays non-stop. Is it possible to achieve breakthrough starshot? Yes, in principle. As I have stated, there is no physical law that precludes any of this from becoming a reality. But that doesn't make it simple, realistic, believable, or even achievable at our current technological levels, or reasonable projections into the near future of our technology. Is it possible to build a spaceship that is compact and light? Is it possible to build a laser so powerful? Will a mission like this be able to withstand the rigors of outer space? There isn't a simple yes or no answer. The real question is whether we are willing to invest enough money to see if it is possible. So to answer the question, at least in this lifetime, for centuries to come, at least the Homo sapiens will definitely not be able to go on interstellar travel. That's all about it for now, until further discoveries or advancements in technology are made. Subscribe to Explify to stay updated about this topic. Check out our other video on space and travel. See you in the next one.